demonstration of ShieldX integration with the new AWS VPC Ingress Routing enhancement. ShieldX offers the first security solution to take advantage of the new VPC Ingress Router enhancement. This video demonstrates ShieldX operation of VPC Ingress Routing in an AWS data center's north-south traffic flow. What you'll see in this demo in a moment is an attacker breaching a workload in an AWS tenant. Down here is the targeted victim, a web server on which a known vulnerability resides. But with VPC Ingress Routing, the incoming packets are routed to the ShieldX Flow Inspector, or FI, via the FI's network interface. And by the end of this demo, you'll see that ShieldX's automated orchestration, deep packet inspection, and advanced security controls block the exploit, perform virtual patching, send an alert to the ShieldX administrator, forward the PCAP to the sandbox for behavioral analysis, and generate logs, dashboard visuals, as well as IOP patented mappings of each kill chain stage event, while also providing detailed intel and visualizations in Maps, Kibana, and the ShieldX Event Explorer, all of which is instantly available to the security analysis and remediation teams. Note that when that victim workload's compromised, this can allow a threat to move laterally along east-west traffic flows. But ShieldX also deploys east-west FI insertions and advanced security controls to layer 7, so the exploit doesn't stand a chance. With VPC Ingress Routing, AWS data centers are now fully and continuously secure for both ingress and egress, with ShieldX able to detect malicious activity in any direction, such as inbound or outbound command and control communications, for example. And even when ShieldX is performing security inspections with AWS Tap Monitoring mode, which we'll demonstrate first, and during which no inline blocking can take place, ShieldX nonetheless detects a north-south breach and any attempt made by the attacker to move and spread laterally, and will alert the data center administrator while generating intel about the event and about any related anomalies in traffic flows. So, let's step through the product briefly to demonstrate AWS Ingress Routing integration with the ShieldX Elastic Security Platform. So let's begin the demo by looking at the AWS Route Table Edge Association tab. Here you can see the ingress routing for traffic coming into the VPC and through the Flow Inspector security instance that ShieldX deploys into the data plane. The display of the AWS Edge Association is specific to the Internet Gateway of the VPC in the Oregon region, in this case. So any traffic entering the Internet Gateway is redirected to this network interface on the ShieldX FI. Prior to this AWS enhancement, route tables in a VPC could only be associated with subnets. So this is huge. All incoming traffic is routed to the ShieldX network interface, or ENI, and this is when ShieldX sees the traffic and applies its advanced security policies, providing both inbound and outbound security inspection and VPC protection. From the ShieldX Management Console, in the Event Explorer, you can verify incoming traffic on any open internet port. So creating a ShieldX infrastructure connector is what instantiates discovery. Here you can see initial AWS data center asset discovery has taken place and is now a continuous, ongoing operation. Continuous discovery means continuous data center visibility as part of continuous traffic inspection and monitoring, as detailed and visualized in ShieldX Maps. All AWS traffic routed by the Ingress Router is monitored and visualized by ShieldX in its asset maps. So now that we're set up in AWS with an established edge association and the VPC Ingress Router is actively routing incoming traffic to the ShieldX FI, we'll next test the Ingress integration with ShieldX FI inspection by verifying security detection and alerting of an AWS Tap Monitoring mode deployment. We'll do this by exploiting a known vulnerability in a web tier application. So let's go ahead and do that by uploading a vulnerability file for Ingress. And here, immediately, we can see in the ShieldX dashboard, in top and detected threats, this inbound vulnerability is detected by ShieldX. It's a file called jQuery upload, and it's running on port 9001. And here, you can view the ShieldX generated log of that attack packet. We're currently in tap mode, so no blocking will take place until we change to an inline insertion mode, which we'll do in a bit. But as you can see here, the jQuery upload exploit has breached the machine that hosts the web server, an event we can also see here in the terminal for that web server. ShieldX tap monitoring has detected the breach. Next, we upload the Eternal Blue malware to exploit the vulnerability on the compromised web server. And now we can see that detection too in the top end detected malware widget shows ShieldX detection of the Eternal Blue malware exploit. Next, let's go to the ShieldX Security Analysis Event Explorer to review intel about this breach and attack. Here are all the permits on destination port 9001, which show there was a configured ACL allow action, so ShieldX tap monitoring permitted all of these connections. And now, if we select threat prevention as the event type to display, up here, you can see the threat, jQuery upload, and also see the alert generated about this event. And over here, there's an option to view the packet capture log from the attack. Now, if you select event type malware, you can also see the Eternal Blue malware attack against the web server. Next, we can go to ShieldX Maps and see over here in the US West Oregon region, ShieldX's patented indicator of pivot IOP technology is using continuous discovery asset mapping overlays to pinpoint and detail the specific web server workload victim that's been attacked. With ShieldX, there's no torrent of noise and data for you to sort through to identify a threat or attack. And there's more. Although these detections and alerts took place in an AWS tap monitoring mode deployment, which means there was no ShieldX blocking or prevention, because we need to be in line for that, ShieldX certainly does block threats and prevent lateral spread of propagating malware, and also prevent sensitive data loss in north-south, outbound south-north, and east-west traffic flows. So let's take a quick look at inline blocking and threat prevention. Here, in the SPS, ShieldX Security Policy Sets tab, we currently have an all-inclusive SPS that includes malware, threat prevention, and URL filtering alerts. So now we'll create a new policy. It takes just a few seconds to configure threat prevention with blocking by making a copy of all threats, editing it, and in combined threats, setting the action to block for this jQuery upload threat. We already have packet capture enabled, so now we'll click here to enable blocking. And here it is, the new policy, all threats blocked. Next, we'll return to Security Policy Sets and configure one more new policy, a copy of all-inclusive called all-inclusive block. It will change threat prevention to all threats blocked, and then save. Here's the new security policy set called all-inclusive block. So now we can apply this policy by going to Access Control, where we set the SPS to all-inclusive block, and save. That's it. So now you will not even be able to do the file upload. ShieldX will block the threat on ingress via the AWS VPC Ingress Router technology. So let's verify the blocking on ingress. Here we see the deny events on port 9001, and when we go to that specific threat event, we see it's been logged, alerted, and denied under the action column. And there's a packet log again to view as necessary, and you can see the advanced security policy set used for this blocking was our all-inclusive block, as expected. Back to the ShieldX dashboard, we see in top end detected threats that jQuery upload on ingress was blocked, denied. And we can return to ShieldX Maps and see that IOP has again identified the incoming north-south threat blocked by ShieldX and prevented it from spreading laterally east-west between app tiers or even between workloads. And that is so important. ShieldX deep packet inspection and continuous monitoring also protects east-west traffic flows. Most enterprise traffic, when it moved to the cloud, became VPC east-west traffic. East-west traffic flows between data center devices, applications, and workloads, and rarely leaves the data center. So in addition to ShieldX Asset Discovery, which you've seen in ShieldX Maps, ShieldX's automated policy generation feature discovers all application tiers and their logical connections in the VPC, as well as all common services like NTP and DNS servers and their logical connections. And ShieldX automated policy generation then proposes security policies for protecting those discovered tiers and services. And even greater, it also implements the recommended security policies between those tiers and even between workloads on the same subnet. ShieldX's automated policy generation provides east-west security enforcement to Layer 7, and the extent of the automation is significant. Automated application discovery, automated network and threat prevention security policy generation that achieves tier generation, tier isolation, microsegmentation, and lateral movement threat prevention. So this is very powerful, comprehensive east-west security that complements AWS Ingress Routing and ShieldX's north-south ingress and egress security detections and enforcements. In conclusion, we demonstrated ShieldX detection of a Layer 7 attack that ShieldX then summarily blocked, securing the AWS data center. And certainly, ShieldX is immensely excited to be one of the first to introduce the AWS Ingress Routing innovation to continuous cloud monitoring, in which agentless ShieldX FI insertions automatically detect malicious attacks and anomalies in both ingress and egress traffic flows, while providing advanced and comprehensive protective security controls. ShieldX. Discover, automate, secure.